100 ml sample of 10 moles of NH3 has a Kb of 10 to the negative 5. What is a pH? Nice. So this one is a multi-step question where we do need ice tables and also need to make sure we know what we're solving for here. But first, let's just simply write down what the formula is, okay? So the question actually, so 100 ml of 0.10 moles of NH3 has Kb of 1.8 times 10 to the negative 5. Okay, what is the pH? So for this, what I like to do is start by writing the equation. NH3, okay, plus H2O turns into NH4 plus OH minus. Now this is key because this tells you that it's working as a base. As we remember when we discussed earlier, NH3, it has that lone pair, attacks the hydrogen, and so we form that conjugate acid. This is important because Kb formula, okay, is going to be what's it called, conjugate acid and OH minus over, well, I guess it's HA over A. I guess, yeah, HA plus technically. So this is a Kb, right? Because you still have your reactants, your products over your reactants, okay? So we still want to do an ice table for this, okay? Initial change equilibrium. And we have the wrong one. HA plus, let me put it closer, and OH minus, okay? So it says 100 mils of 0.10 moles per liter. We actually only need the concentration because you see here the Kb formula only uses concentration. So because of that, we only need that 0.10, okay? And now, okay, we want to find out how much it changed. So that would actually be, the initial for each other one would just be 0. Nothing is associated yet. That's how we mark it. Now the change is going to be minus x here, okay? Because whenever it loses whenever it loses something, these two gain that same amount that it lost, okay? So it'll be 0.10 minus x as a final part in equilibrium, and these two would just be x. Now, to see if we can use a shorthand version, let's see if the concentration is at least 1,000 times bigger than the Kb. So what we do is we do 0.1 over 1.8 times 10 to the negative 5 divided by 1.8 e negative 5. Okay, good. This 0.1 happens to be 5,000 times over, so that's 5,000 times minimum. So it's greater than 1,000 times over, meaning that we actually do our shorthand, that this change would actually just be still around 0.10. The x is so inconsequential that it kind of just phases out as it's not included. So our real formula now is just Kb is equal to x squared over 0.10. So we multiply 0.1 to the Kb, which we know is 1.8 times to the negative 5. So 1.8 e negative 5 times 0.1, and then you square root the whole thing. Okay, so then with that you get, let's see here, 0. Well, after solving everything, you multiply that together, you get x is equal to 0.0013. So yes, we were definitely right in saying that the amount was almost inconsequential. Subtract that from 0.1. When you round it, you still get around 0.10. Okay, so now we know how much HA plus was produced and also how much OH minus. So this is a concentration of OH minus. That's a part that's important because this allows us to calculate our POH. But you're probably wondering, they say pH though. We'll get there, don't worry. So with that being said, we first want to turn this into POH by doing the negative log of concentration of OH minus. Okay, and what do we get? So negative log of the answer we just got, our POH is equal to 2.87. Now the relationship between POH and pH is that pH plus POH is equal to 14. So 14 minus POH is equal to pH. So 14 minus that answer gives us our pH. So what is the pH of this question? The pH is equal to 11 points. We want to do two significant digits, and it's always after the after the decimal for pH. So 11.13. That's what it rounds up as. So that's a pH. So because if you notice exactly, NH3 works as a base, and that's why they gave us the KB. So when they give you the KB, just know that you actually find the concentration of your hydroxide ions. And when you find the concentration of your hydroxide ions, you actually find the POH when you do the negative log part. Okay? And so to get to pH, you need to make sure you do 14 minus the answer you got. Okay? So with that, that is really all there is to this question. It was quite a bit of steps. Make sure you know how to do your ICE table. Make sure you know how to make the question easier, so you don't have to do like the whole quadratic equation. Because exactly, when you subtract, let me even show you. When you subtract that answer you got for the concentration from 0.1, you get 0.0986, which rounds to 0.099. Which can also still just round to 0.1 depending on how you want to do it. So exactly, that change is almost inconsequential. So exactly. So they did this formula, which is actually what we did. Amazing. That's the first formula we started with. And we got our hydroxide ions. Good. They did the ICE table, which is good. Initial, change, and equilibrium. And they did products of reactants. They did the KB, but they did not make it easier for them at all. Yeah, actually, it's funny because we still get around the same answer, because we got 1.33 using the quadratic equation here, and we got 1.34. So as you can see, you can definitely use that estimating way as long as the difference is at least over 1,000. Okay, so now let's see what else they did. Exactly, now they see that concentration of OH is the 1.33 times 10 to the -3. Yep, negative log of that, POH is 2.88, and then they did pH 14 minus POH, and they got 11.12. I got 11.13. It's pretty much the same thing. Usually they give you a range of what to work with. So this is correct. So exactly, as I mentioned, you can definitely solve it using the quadratic equation as well. It just takes a little bit longer, which is why we have that simplifying rule if